software. I'm actually here with Michiel van der Visser. We both work for Mine Technology, and the brand that we have is Klein. So I'm going to share a screen. We're going to start with a little bit of PowerPoint, and should be able to see our PowerPoint screen.
All right, you're good. You're on.
Okay, great. So as I said, we're here with C4 Technology, with C4 Systems on their boat, and we're sitting out in Long Beach Harbor at the moment. I've got Michiel van der Visser with us. That's Michiel's photo there. We're going to demonstrate the Klein 4K survey system. What we're going to cover is an overview of the system. We're going to cover our automatic target recognition. We're going to show you how we deploy and retrieve a side scan. And we're going to go through some very basic setups of HYPACK, because Daniel's already showed you how to set up HYPACK with side scan. We're then going to go and have a look at our software. We're going to put the sonar in the water, look at the sonar data in Sonar Pro, and then we're going to look at it in HYPACK, and we're going to do a real-time mosaic. And the quality of the real-time mosaic, we're hoping will be good enough to actually be accepted as a final product. So just in terms of the sonar system that we're demonstrating today, this is this 4K survey system over here that's highlighted. It's a 300, 600 kilohertz system, and it's designed for the professional offshore renewable cable route and oil and gas survey market. Right, so this system is actually been designed by surveyors for surveyors. So it's got a lot of unique features in it. Some of the unique features are, it's a simultaneous dual frequency side scan, 300, 600 kilohertz. It has a dedicated 300 kilohertz altimeter, pressure sensor, and heave pitch roll sensors. Now, this altimeter saves you a huge amount of time in processing your data, and the sort of calculations I've done is that you can save about 40% of the time when you're actually generating a mosaic. You can get about 250 meters of range off the 300 kilohertz system and about 120 meters of range off the 600 kilohertz. It is depth rated to 2,000 meters. And I mentioned the bottom tracking. It's been optimized for something that we call true bottom tracking. So you seldom get any errors in your bottom tracking. It easily interfaces to magnetometers and USBL systems, and it meets standards for offshore renewable energy and gas. One thing that's really important when you're doing surveys in renewable energy areas is that it's generally pretty windy. So your side scan is going to suffer from motion. It's going to be moving up and down. Now, we actually make our side scan arrays at Klein to be motion tolerant, and we achieve this through using different beam widths between the transmit and receive arrays for each frequency band. And this means that a system like the Klein 4K survey is ideally suited for high resolution professional surveys in more marginal sea conditions. I'm just going to swap across to Michiel here, who's going to talk to you about towfish positioning.
All right, so Daniel already addressed it this morning about towfish positioning and the importance of it. So right now we're gonna run off the boat, and we're actually just using a sheaf, and we have marked our cable at a specific interval, so we know how much meters of cable we have out, which we have done a 5 and a 10 and a 20 meter interval. It's pretty shallow over here, so that works fairly easy, but especially when you're in areas where you have more shallow and deeper areas, and where you're constantly like moving your cable out, I highly recommend to use a cable counter, which automatically will be inputted in either our software or into HYPACK, and it automatically calculates the position of the towfish. So there's another option for you, but the more expensive option, as Daniel has said as well, is our acoustic positioning, our USBL systems that you can see on the right here. The middle picture is the head basically of the USBL system, and on the right we show a responder that's mounted to the cable that acoustically will send its position to the mother ship. So we're going to go to the next slide where we actually have some images of this particular 4K survey system while we were out last year with NOAA at the Stellwagen Bank out of Boston, and we found this old ship, the Portland, that has been there for a while, and you can clearly see on the shadows of the structures that are still up, as you can clearly see the stack and the main features of this vessel. Here's the waterfall as you would see it as an operator coming by when you're operating the system. So the waterfall is coming down, and we've got the ship right there. It actually was sticking out a little bit, so we were lucky that we didn't hook our towfish in this particular case. This was in 120 meter water depth. Another couple wrecks that we found were actually the Palmer and the Louis B. Carey Collier. They sank in 1902, so they're fairly old boats. So one is a 5-mast barge and the other one is a 4-mast barge, and they collided, and they're also off the coast of Massachusetts. This is unprocessed data, and this is how it would show up on your screen while using this 4K survey sonar system. And I'll switch over back to Pete.
Okay, thanks, Michiel. Thanks so much for keying us in on towfish positioning. What we can do as well is feeding our system into HYPACK. We can process the data to a final process mosaic, and this is fairly typical of a mosaic you can process in HYPACK. Very good resolution, very good feature matching, and a mosaic like this will probably take me about half an hour to produce, so it doesn't take that long to actually produce this. And this is the 300 kilohertz channel that's been mosaiced here. Right, so one last thing that we're going to talk to you about is that if you're buying Klein sonars in the future, you're going to get a copy of our automatic target recognition system, which was launched at Oceanology 2 weeks ago. And what this does is it actually can work in a real-time manner or post-process manner and automatically pick targets in your side scan data. I'll give you an example here. Here we've trained it to find German torpedoes, and the system's going through the sonar data, and you'll see it will start to pick a whole bunch of torpedo targets. And I'll just show you a couple of them once they've been detected. So let's get that video started again. Right, so if you have a look here, it's picked a whole bunch of targets, and here are the torpedoes. So you'll be getting this system with any new Klein sonars, and there is a subscription model that's available for continued use of the system. This is a massive time saving in terms of processing and detecting objects like torpedoes or soft body targets or UXO. So you can chat to us at the booth about the system. Right, so where we're working at the moment, we're sitting offshore with the seafloor boat, and we're going to be working on some lines down in the south here. Just let me try and get my mouse working. You can see at the bottom of the image we've got 3 lines, and that's where we are at the moment, and we're going to start working in that. Just quickly show you how we deploy the towfish. This is deploying the towfish. In the water, you can see Tyler's a pretty strong guy. He can put it in on his own. Gil's handling the cable. Towfish has now been deployed. Letting out the cable. We've let out 5 meters of cable. Now going to secure it in our K-grip system. And it's now secured with K-grip. We need to. So I'm going to get out of PowerPoint. Just minimize that. And so the sonar's been deployed now, and you can see that we are actually collecting data. Now this is in Sonar Pro itself. What we're going to do is just quickly go into HYPACK and just show you This is the area that we're going to be surveying in a couple of minutes. And in terms of the geodesy that we've set up for this particular project, we decided to use State Plane NAD 83, California Zone 5, and let's keep it local. We're working in a local coordinate system here. In terms of the hardware, it's really easy to set up in HYPACK. We've actually got an Applanix POSMV on board, and we are sending out serial data to HYPACK from the Applanix. So this is serial positioning and heading and speed, and that goes under the boat hardware mobile. We've then got a second mobile, which I've renamed the side scan mobile, and this has been positioned using the Towfish DLL. And the setup for this is really easy. Just to go back to the GPS, we've just connected this to COM3 at 19,200 baud rate. Going back to the side scan mobile, got the Towfish DLL. On the setup, we are using manual cable output. We have a catenary factor here to actually correct for our layback, and we have the sheath block offsets actually input in that, and that's all you need to do. And then we've connected the client just over the Ethernet. There's the client IP address, and that's as simple as that. The hardware took me about 1 minute to configure, and we can go from there. So we're just saving our hardware. We're going to have a look at what the data first of all looks like in Sonar Pro. So if we just start running some nice straight lines now, we'll see what the data looks like. Just returning. Let me just clear the navigation screen so you can see where we are. So we've just completed our turn now, and I'm just zooming out a little bit so you can see where we're working. So we're running south at the moment, and this indicates this is the starboard side, the green of the Towfish, and the red is the port side. We've set the Towfish to 50-meter scan range, which means we are acquiring 100 meters of swath data. What's really impressive is you can see how well the bottom tracking is working right through our wake. And this is due to the 360 kilohertz single beam echo sounder that we have in the tail of the Towfish. So as we've straightened up, we're still seeing a little bit of our boat wake on this side. This top screen is the 600 kilohertz data, and the bottom screen is the 300 kilohertz data. So now that we've got rid of our boat wake, we can see that we've got rock solid data all the way to the edge there. That's 50 meters out. What is important as well is that you fly the Towfish at the correct altitude. Now, the method for actually doing that is between 10 to 15% of the scan range. Here we're using 50-meter scan range, so 10% of that is 5-meter altitude, and 15% of that is about 8-meter altitude. So we are approximately flying it at about an 8-meter altitude here. So what we're going to do is we're going to start recording the data, and this is recording in our proprietary STF format, and we're going to go past an object now. This is an underwater buoy that's actually anchored, and we should see some structure that actually comes up off it. And there it is on the starboard side. You can see that quite nicely. This is the 600 kilohertz, and this is the 300 kilohertz. I accidentally just generated a target there. Just let me delete that. Okay, the other window down here is our sensor window, and here we can see our altitude, our Towfish depth. You can see we are only towing the Towfish about 3 meters under the water, and here you can see the Towfish heading, the pitch and roll, and the speed. We're going at about 3.7 to 4 knots at the moment. So you can see how lovely the data quality is with the system. Notice the very robust bottom tracking that you can see here as well. Right, so what we're going to do is, seeing as this is a HYPACK conference, we're going to go across onto HYPACK. We're going to continue recording in Sonar Pro, but we're going to start up HYPACK itself. Right, so there's the HYPACK shell. These are the 3 lines that we want to survey, and we're going to start surveying now. Right, so Daniel, you should be seeing the HYPACK screens coming up now. Can you confirm? Okay, thanks.
Yep, you're good.
So what we can see here is we've got a model of the boat and we've got a model of the towfish. So you can see how close the towfish is actually being towed behind the vessel. And that's all very nice. So we've got this nice feedback in the map window. Right. Over here, we can see the side scan waterfall data. Here's the cable out. We've got 5 meters of cable out. So we can output a lot more cable if we want to. And you can see how the towfish feeds itself back over there. So we'll bring in cable to its correct distance. And you can see the towfish coming closer and closer to the vessel. So we've got 5 meters of cable out at the moment. So there's the 5 meters of cable out. In terms of the side scan waterfall data, you can see how robust the bottom tracking is here. We are looking at what HYPACK calls frequency 2, which is the 600 kilohertz. So we can also look at frequency 1, which is the 300 kilohertz data as well. And this will start coming in. It'll take a little bit of time for the TVG to organize itself. Let's just put on the auto TVG, and now we can see the 300 kilohertz data. Notice again how rock solid the bottom tracking is. It ignores all this noise in the water column. Right. So when you're doing a real-time mosaic, whatever frequency you have selected here in the first window is the frequency that will be mosaicked. So we are going to use the 600 kilohertz to mosaic it. And if I can ask Chris to come up towards line 1, we can start the real-time mosaicing. Now it's as simple as going to this little button here, setting up the size of your real-time mosaic, and we're going to do a 10 centimeter real-time mosaic, and we're going to collect this while we're logging. So as we approach the start of the first line, we're getting up to it. Yeah, we're on our way. It'll take us a minute or so to get there. The nice thing about HYPACK as well is that you can actually target on your mosaic or you can target on the waterfall. Notice again how good the bottom tracking is. We've got a shoal of fish over there and over here. The bottom tracking has actually ignored those fish. This robust bottom tracking helps you a lot with your final processing and also helps you to produce a really good mosaic. There are 3 ways to produce a good mosaic. You have to have a good sonar to start with. You have to be able to position the towfish correctly, and you have to have very good bottom tracking. If you have those 3, you can actually do a really good real-time mosaic. So we think we have all 3 on this iteration. See, we're flying about 9 meters off the bottom, so it's a little bit high, but we don't really want to put out too much more cable because at the end of the line, the depth shallows quite a bit. And you can see that.
Hey, Pete.
Yeah.
Can you brighten up the waterfall just a little bit? It's a little dark on the projector.
Okay.
I think if you raise the auto TVG sigma, it might come up, or you could do the brightness in here.
It looks fine on my screen. Let's see. I'll raise the auto TVG. Any better?
Yeah, that's a little better. It just comes through a little dim on the projector.
Yeah, okay.
That's great.
Is that better? Okay, we'll leave it at that setting.
That's good.
Okay, great. So that's just the projector. My screen looks amazing. Okay, as you see, we're approaching the very first line there. And the minute we start logging, we'll start producing the real-time mosaic. Right, so hopefully we'll be able to see some interesting things in the data on these lines. There's a couple of obstructions marked in the chart. We don't really know what they are, but let's have a look. Right, to start the real-time mosaic, as I said to you, we just have to have this radio button set up to say enabled, and we're setting up a 10 centimeter resolution, and the minute we start logging, we are now seeing our real-time mosaic coming out of the towfish. So this is pretty impressive that you can actually do this. Now, what we've done here is we've set the side scan on 50-meter scan range, which is giving us 100 meters of swath. And how we space our lines apart is we want some overlap between the data. So we've spaced the lines 80 meters apart, which is going to give us about 20 meters of overlap, which accounts for a couple of steering errors and things like that. And that's going to allow us to be able to produce a good real-time mosaic. So I'm going to start zooming in here to show you what the quality of the mosaic is. And you can see that the bottom tracking is allowing us to do a pretty nice job. And we're starting to see a target here. Oh my goodness, that's a wreck. Look at that. It's a wreck of a small vessel. And there it is on the mosaic. So what we can actually do is we can target that. We can have a look at this wreck. We can measure the length of it. So let's get some idea of the length of this. It's about 6 meters long, so it's a small pleasure craft. And we can just label it as well if we want to. Wreck. Okay, so we now have our first target marked. You can see it's actually marked it on the real-time mosaic. And oops, we got a bit of a heading error that's come in there from the POS. That should fix it up. So we have our first target that we've actually marked. Looks like we have something else that's coming up. Now you can see these little gaps here. That means that we've probably set the resolution of our mosaic to 10 centimeters, which is maybe a little bit ambitious. So what I'll do at the end of the next line is I'll make it 20 centimeters and we won't actually see these little gaps in the data. Again, we had a little glitch in the heading over there. That's not HYPACK's fault. We're coming to the end of the line now. I'm going to stop logging and I'm just going to change the resolution of the real-time mosaic. Oh, we've got another wreck. How's this? Look at this. That's great. Really, really nice. We've got 2 wrecks on that line. So those obstructions that were marked on the chart are actually wrecks. Right. I'm going to stop logging now. And we're going to turn on to the next line, line 2. Let me just change the navigation screen to line 2. And I'm going to just change the resolution of that mosaic. The minute I do that, it's going to mess up my last line, but this is a live demo. These things do happen. Right, so now we've set up a 20 centimeter mosaic. And once we straighten up, we'll start logging data again. Right, almost straightened up. Coming onto line. Right, you can see the towfish following the boat nicely. HYPACK does a great job of actually doing this. And here we are. Now we're doing a 20 centimeter real-time mosaic. And let's see if there are any other interesting targets in this area. You can see a couple of small targets over here. Let's go zoom in a little bit and have a look at them. Here you got a couple of small targets here. Don't really know what they are, just some debris. So what this is actually doing is HYPACK's generating geotiff images in the set of tiles. And once we close out survey, you can actually plot these up in the shell, or you could copy them onto your flash drive and hand them over to your customer as a preliminary product. You can see how well the bottom tracking is working. We've probably got a bit of turbulence that's coming off the bottom, suspension, and the bottom tracking has actually gone straight through that. So again, good secret to real-time mosaicing is you've got to have robust bottom tracking. Oh wow, look at that. That's a shoal of fish. It is a massive shoal of fish there. Look how it shows up on the mosaic. That's impressive. That shoal of fish is about 20 meters in diameter. That's an impressive shoal of fish. If we zoom out a little bit, we can see our coverage that we've got so far with respect to the background S57 chart. Right, we're coming up towards the end of our second line. We haven't seen too many. On the first line, we saw those two lovely small wrecks, both about 6 meters long. So a little pleasure craft that have obviously sunk in the area. Pretty sad for the owners. You can see the pock marks in the bottom here in the side scan data. Very high resolution data. There's a target over there. Let's click on it and see what it is. Looks like a piece of pipe to me. Let's go and zoom in a little bit. Yeah, no, it's not pipe. It just looked like some type of object. Measure the length of it. Here it's about 5 meters long. You can also measure the height of that target as well using the little height tool. And you can measure the length of the shadow. And so it only sticks up about 12 centimeters off the bottom. Right, so we've ended that line now. We're going to stop logging. And there's line 3. I'll just get the navigation running. So we're going to do our last line now. It's generally not a good idea to mosaic data on the turn. You can record the data, but mosaicing on a turn can cause stretching in the imagery. I have been successful on a couple of occasions mosaicing on a turn, but it's not good hydrographic practice.
Yeah, it's good to pay attention to the quality of the data here as it goes through a turn, and you can see it's you don't want to try targeting in that.
That is 100% correct, Daniel. Okay. Yeah. So now we're starting to approach our third line. Now this is a 20 centimeter mosaic. I started off with a 10 centimeter mosaic and it was leaving a couple of holes. So we've gone to 20. But we may as well start logging the data now. Chris, our skipper, is doing a great job of keeping us online. And here we go. Well, we got a couple of heading errors there that have come through on the NMEA, but those will disappear pretty soon. You can see the amount of overlap that we've got. We've got about 20 meters of overlap on each line. Oops. That's not HYPACK's fault. That's just coming through on the serial port. Okay, you can see the very nice blending between the two lines here. I'll go and zoom in. Daniel's done a great job of this. Look at that. Great blending between the lines. It's almost seamless. Now we actually need to filter this heading data that's coming out. It's giving us the odd little heading spike. Let's see if that shoal of fish has moved as we approach it. Here's the shoal of fish. They've probably moved off. You can see we haven't changed our layback at all. We're still running 5 meters of cable out. Again, we had another heading spike. I can probably get rid of that if I just went into the POS and just did some changing how we actually outputting the heading information.
As well.
Yeah, we're coming towards the end of the line now, and didn't really see any decent targets on that line, but this small little survey has yielded 2 wrecks, which is quite nice. Yeah. There's an object on the side here. You can see the shadow that it's actually casting. See this object over here? Fairly big shadow. And you could measure the height of that object pretty easily just in the HYPACK target window. There's that feature targeted. Right, so I'm going to log off here. We've come to the end of the line. Stop logging. And yeah. Daniel, any other questions that you've got so far? I'm going to start a new mosaic as well. We're going next to the pier, and let's see if anybody has any questions while we're logging data.
All right, yeah, I'll open the floor. Does anyone have any questions they'd like to? Yes, Gary.
Can you ask Peter to zoom out so we can see where he is in relation to the shoreline?
Sure.
Sure. Oh, he's got you.
Excellent. Thank you.
Yeah, good. This is a narrow little pier that comes out, and then it comes into more of a solid wharf. And this is where, oh, there's another feature down here. Look at this. Looks like another wreck. Well, Mikhail's telling me he thinks it's a car. That's interesting. Look at that feature over there. These are the shadows from the piles. We've actually found quite a lot. Yeah. Yeah, there's a lot of debris on this side as well. You can see the beautiful quality of this data and the robust bottom tracking. Let me go zoom in a little bit and you can see the real-time mosaic.
Yes, Andrew.
So I noticed we started with a 10-centimeter, brilliant, pretty high resolution image. Have you seen it get bogged down with certain size limits?
Yeah, the question was, is there a sort of memory limit or a resource limit in terms of cell size for the real-time mosaic?
No, not from the HYPACK point of view. You've just got to look at the speed that you're going and your long track ping rate, and then decide on that. My experience is that a good number is about 15 to 20 centimeters, and you're going to get a fairly solid mosaic. If you're going a lot slower, at about maybe 2.5 to 3 knots, you can get by with a 10-centimeter mosaic, and you're going to have enough for long track resolution to populate that mosaic. And the beauty about this is these are geotip images which have been saved as tiles, and you can just switch those tiles on in the HYPACK shell at the end of the day, and give your customer a screen grab or give him those geotips.
All right, any other questions?
How often is it saving them? How big are each of those geotips?
The question is, how big are the geotips and how often does it save?
Daniel can answer that.
Yeah, it saves them as a grid, and the size is dependent on the resolution, so it changes, but it's saving, as they're being written, as they're being generated.
You don't need to save to set this up as you would if you're going to do a matrix.
Correct, it's automatically saving. Any other questions? All right, we're not seeing any more questions just yet. If anyone has anything they want to bring up, we still have 25 minutes left in the presentation slotted for us.
So what I'm doing here, Daniel, is I'm breaking all the rules. I'm mosaicing on a turn.
And nothing's catching fire.
Yeah, nothing's catching fire. It's breaking all the rules and mosaicing on a turn.
And I don't hear any police, so.
Slow down a bit. Okay, we're just slowing down a little bit, so we're going a little bit fast here. So. Yeah, the thing with side scan is the slower that you go, the more pings that you have on an object, and the better your data resolution is going to be at the end of the day.
All right. Is there anything else you wanted to show us, Peter?
No, I think that's pretty much it. If there are no questions from the customers, I'll be available at the booth. Give me about 20 minutes. I'll be available at the booth to answer any technical questions.
Yes, Garrett?
Will you use this data for your next session?
Will I use this data for my next session? I can, yeah. If Pete's back in time, I can grab that off the flash drive and we can process it.
I wouldn't recommend it, Daniel, because I'm probably not going to get back quick enough for that.
All right. Unfortunately, we'll have to use some of my prepared data.
Would have been just interesting to see the heading, editing the heading. Set it up.
Right. All right, you guys are welcome to sit and watch, but I think Peter's going to head off in a minute, and I release you. Thank you for watching, and I'll see you guys at the next session.
Great, Daniel. We'll stop and log off now.
All right, thanks, Peter.
Thanks, Peter.
I'll see you in a bit.
Okay, see you.
Bye.